Okay, today is the day that I hate because this is the hardest transformation. Okay, you introed it slightly yesterday, all right, but you just got the elementary school version. Okay, we've talked about translations where we slide, reflections where we flip. Today is where we're going to talk about rotations. All right, a rotation is where we turn a figure. Okay, we're going to turn the shape in some way around a certain point. Whatever the point is that we rotate around is going to be called the center of rotation. A lot of times we use the origin as our center of rotation, but not always. Okay, so we need to be able to rotate around any point. All right, so I'm going to demonstrate how we do that because a lot of you could look at a triangle and tell when it's been rotated. Okay, we could tell that, what is it? We could tell that that's a rotation. All right, we turned around the origin. Okay, so recognizing a rotation is really not that difficult, but actually performing a rotation can be. Okay, so obviously one trick that you can do, and this is just to see what the shape should look like, is you can actually turn your page. All right, rotate the paper and see what your shape should look like as a result. But what we're going to need more specifically is actual points. Okay, now before we can get into actually rotating some figures, some examples, there's a couple things we need to understand. We need to know the terms clockwise and can you guess the other one?
Counterclockwise.
Oh man, y'all are so smart. All right, counterclockwise. Now, hopefully, I know everybody in this day and age uses digital watches and stuff, but hopefully you've seen a clock, a regular clock, enough to know that clockwise is going to go in this direction, just like a clock's second hand ticks. All right, whereas counterclockwise is going to go the opposite. I am pretty talented. All right, so anybody not sure about clockwise, counterclockwise? Good. All right, the next thing that we need to know is the measurement of rotations. Okay, now you're going to get, let's say that this line is the line that we're going to rotate. Okay, we're going to rotate it around this red dot here. Okay, now we'll start off clockwise. Okay, which means we're going in this direction, right? So, how many degrees would that rotation right there be?
90.
That's a 90-degree rotation because it makes a 90-degree angle, right? Okay. What about, so I'll put, that's 90 degrees. Okay. What about that?
180.
Good. That's 180 degrees. Now, I could say this right here. What would that be?
270.
That would be 270 degrees. But here's what I want you guys to see. A 270-degree rotation going clockwise is the same thing as a 90-degree going counterclockwise. Everybody see that?
Oh, yeah.
All right. So, a lot of times we don't see 270-degree rotations. Okay? Most of the, and it's I don't know if I've ever seen one on a STAR test. You typically see 90 degrees and 180 degrees. Okay? So with a 90-degree rotation, you got to know the difference between clockwise and counterclockwise. What can you tell me about 180 degrees?
That's a reflection.
It's not a reflection. No, and here's why. If this is the triangle and I rotated 180 degrees, it would be like that. All right. It's not a reflection. Okay, it actually turns around. Okay, let me go counterclockwise here. What can you tell me about 180 degrees? Doesn't matter, right? Clockwise and counterclockwise doesn't matter with 180 degree rotation. In fact, most of the time, they don't even tell you clockwise or counterclockwise when it's 180 degrees. Right? They'll say rotate this figure 180 degrees about the origin. Okay? And that point will rotate around the origin. Okay? So are there any questions about degrees of rotations, clockwise or counterclockwise? No? All right. Let's get into some of the harder stuff then. Yay. All right. We'll start off with a triangle. We'll go here, here, here. Okay. This will be triangle A, B, C. Now, we're going to rotate this. We'll go 90 degrees clockwise. Okay, now, here is the method for doing this, and make sure you're paying attention to this, okay, because this is the lesson. Okay, we're going to go 90 degrees clockwise around the origin. So the point that we're rotating around is the origin in this situation. So I'm going to go ahead and mark it. Okay. Now, rather than rotate the shape or the point, we're going to rotate the path to get to that point. Okay, and I know that sounds weird, so just hang in there with me. From the origin, how do I get from the origin to A? I would go up 2, right 2. That would be my path to get to A, right? So, I'll draw that over here. Up 2, over 2, right? Now, I'm going to rotate that path, just like we did on the last one. 90 degrees clockwise means I'm going right here, right? Which means now instead of up to, what direction am I going to be going?
Down to.
No. Where am I pointing at? Right to.
Right to, down to.
Right to, down to. Okay? You know how you know you're going to go the right way if you do this? All right, that's not the same path, right? And I can already hear some of you stickering because, yes, if I went 180 degrees, yeah, it's gonna make a swastika. Now, we don't like swastikas. I understand that. Shh. But it's actually a good way to remember how to rotate your path. Okay, because I see a lot of kids, especially when we're doing a 180 degree rotation. Well, they'll rotate 180 degrees, and they'll do this. Well, that's not going to make that swastika, is it? All right. Now, here's how I remember it. Swastikas are evil, and remember, I don't like rotations, right? So I think rotations are evil too. So that's how you can associate the two. So, yes, you are going to get that shape a lot when we're doing rotations, and it's okay. All right, so, yes, if I rotate that whole path, instead of up to, right to, I'm going to go right to, down to. So, for my new point A, I'm going to go right to, down to. So there is A prime. How do I get to B? What's my path for B? Up 5 and right 3. So, on my paper, I'm just going to say up 5, right 3. I'm not going to actually draw it to scale. All right, so up 5, right 3. Again, I'm going to rotate it 90 degrees. And now I'm going to be going
Right 3, down 5.
Right 3 and down 5. Rotate the whole path.
Right 5 down 3.
Right 5, down 3. Look at it like this. All right, and I know if you're watching the video you can't see this, but I'm going to rotate the whole paper. Ready? Oh, that didn't work. But if I rotate without it actually flipping, you see how the 5 goes to the right now? Okay, so you can actually rotate the paper to see how your path would be affected. Okay, but that path right here going away from our point of rotation has to be the same. Otherwise, you're changing your path. All right, so for my new point, I'm going to go right 5 and down 3. So 2, 4, 5, 1, 2, 3. And there's my new B prime. Now I know this seems like it's taking forever. It's because I'm going very slowly. All right, we'll do another example here in a minute where I go a little bit faster. Now, it does not matter what direction you go first. Let's say for C, I go right 1, 2, 3, 4, 5, 6, and up 2. Okay, so my path is right 6 and up 2. I can still rotate that, okay, which is going to make it do what? It's going to look like an L, all right, but what are my new directions going to be?
Down 6, over 2.
Down 6, and don't say over 2. What direction?
Right 2.
Right 2. Good. So if I go down 6 and right 2, that's 2, 4, 6, and there we go. That is a triangle after a 90-degree rotation. Okay? So, we rotate the path, not the point. All right? It's a lot easier to rotate the path because, yes, it makes that swastika look, and that's easy to remember. But rotating the point is a little bit, you can get that a little bit more confused. So let's do another example real quick. All right, let's say we have this shape here. Okay, we're going to rotate this one. Let's say we'll just do 180 degrees. Okay, so it doesn't matter if it's clockwise or counterclockwise. All right, so we'll say this is A, B, C, and D. So we'll do A first. My path to get to A, I'm going to go up and left. Now that would be up 4 and left 1. So if I rotate that 180 degrees,
You right 4.
nope, I'm going 180 degrees.
Oh, down 4.
Down 4
Right 1.
and right 1. Good. We have to go opposite of the top, right? Because it's going to make the swastika. So that way Coleman can giggle about it. All right? All right, so we're going down 4, 2, 4, and right 1. Okay? So there is the A prime. Okay? Now, with B, I went up 4 and right 2. So when I rotate that, it's going to be down 4 and left 2. So down 4, left 2, there's B prime. For D, I went up 2, right 1. That's going to become down 2, left 1. And that would be D prime. And then lastly for C, we went right 4 and up 1. Okay, that would be left 4 and down 1. There we go. And so that would be a 180-degree rotation. All right, so let's talk about when they have a different center of rotation. All right, so again, we'll have a triangle. All right, now, this time, we're going to go 90 degrees counterclockwise, but we're not going to use the origin as the center of rotation. Instead, we're going to rotate around the point 1, 2. This will be our center of rotation. Okay, so 1, 2 is this point right here. That's our center of rotation. Does everybody see that? So we're going to do the same thing. We're still going to draw the path, but instead of drawing the path from the origin, we're going to draw it from this new center of rotation. So let's say this is D, E, F. All right, so for point D, I went left 1, 2, 3, 4, and down 1, 2, 3. So left 4, down 3. Okay, we're going to rotate that 90 degrees counterclockwise. So that would be this direction, opposite of a clock. Now we're going down 4 and right 3. Good. So if I went down 4, right 3, that would be my new D prime. Okay? We got to do that for each point. All right, so for F, you go down, or you go left. Well, we can go down first. It's 1, 2, 3, 4, 5, 6. All right, and then left 1, 2, 3, 4, 5. So down 6, left 5. All right, we can rotate that 90 degrees counterclockwise. So now we're going right 6 and down 5. Which would put us at, let's see, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. If I could get it to, there we go. All right, and that would be F prime. Okay. All right, and then for our last point, for E, say we went down 2, 4, 6, 8, down 8 and left 3. 8 and 3. We rotate that 90 degrees counterclockwise. And what are my new directions?
Right 8, down 3.
Right 8, down 3. So that's 2, 4, 6, 8. 1, 2, 3. There's my new E prime. And then we go. That's the rotation, 90 degrees counterclockwise. It looks weird because it's not rotated around the origin anymore. Okay? Now, on this next slide, I'm going to show you the algebra rules. You know how we've been discussing the algebra rules. If they're not rotating around the origin, you can't use the algebra rules. Just like on reflection. Remember on reflection, they had to use the y-axis and the x-axis if we wanted to use our algebraic rules. Same thing here. We have to use the origin as the center of rotation if we want to use those rules. Now, the algebra rules are actually, these are the toughest as far as algebraic rules. Okay, when it was translation, we added, subtracted from x to move left and right, added, subtracted to y to go up and down. When it was reflection, if we reflected across the x-axis, we flipped the sign on the y. If we reflected across the y-axis, we flip the sign on the x. Here's how we do rotation. There are 3 different rules. There's 90 degrees clockwise. There's 90 degrees counterclockwise. And then there's 180 degrees. Okay, these are our 3 different types of rotations. Now, for 90 degrees clockwise, we have x and y. And what we're going to end up doing, if it's a 90 degree clockwise, we're going to flip y and x and then change the sign on x. And that's weird, right? So, on a rotation, clockwise, we're going to take y and x and we're going to rotate them. Okay? And then x changes its sign. For 90 degrees counterclockwise, it's the same thing. We're going to take our x and y and we're going to rotate them so that they become y and x. But now, the y becomes negative or positive. It just flips the sign. Okay? 180 degrees, X and Y are going to stay in the same place, but they're both going to have their signs flipped. Okay? These are our 3 rules. All right? And I'm going to give these to you written out tomorrow for you to kind of study on them a little bit. But I promise you, of all the rotation stuff, this algebra the algebra parts that you guys don't like is the part that they ask the most questions about on the STAR test. So we have to make sure that we're putting in our focus on this. Okay? If it's clockwise, the X flips the sign. If it's counterclockwise, the Y flips the sign. Either way, if it's 90 degrees, X and Y are going to swap places. Okay, 180 degrees, X and Y stays in the same place, but they both flip the sign. All right, and I'm going to tell you, they don't give you that on the formula chart. You're going to have to memorize it, and that's a pain. Okay, now, that being said, while I have the video running, let's talk about what you could do on STAR test if you forgot. If you forgot your algebra rule and there's a question over the algebra rule, all you need to do is make a point. Okay, what are the coordinates to that point right there? How do you get to that point?
3/2.
Well, what are the coordinates though? 2, 3. All right, our X and Y are 2 and 3. Okay, now let's say they're wanting to know the algebraic rule for a 90-degree clockwise rotation. Let's rotate that point 90 degrees. All right, I went up 3 and right 2. If I rotate that 90 degrees clockwise, it'll be right 3 and down 2. So right 3, down 2. What are the coordinates to that new point? 3 and 2? Negative 2. All right, so if I started out with X and Y, looking at the result, what happened?
The Y changed negative.
So the positive 3 became a negative 3?
Oh, yeah.
No, they switched.
They switched. The X and Y switched. All right, the 2 went to the second number, the 3 came to the first number. All right, and what else? And then that X that was positive 2 became a negative 2. All right, so that kind of demonstrates what I'm talking about algebraically. Okay, so if you forget the rule, you can create an easy problem, look at the original coordinate and the new coordinate, and see how it changed. Okay, and so that way you can kind of remind yourself of those rules. We're going to look a lot more out at the algebraic rules tomorrow, but I did want to kind of preview that a little bit. Okay, so this is rotations. In my opinion, it's the hardest. Okay, but hopefully after going over it, you see that it's really not that hard. It's just it takes a little bit more time. Okay. If you are confused, I highly recommend that you watch the video again. I know that it's not fun to relive a lesson twice, but I do think that this is important enough that it'd be worth it. Got it?